Good morning, dear colleagues. The reported determination of components for heat storage material is brought to your attention. The reporter is a leading researcher of the Institute of Engineering Thermophysics of NASA of Ukraine, Alina. Today the world is moving to the fourth and fifth generation discrete heating system of heating networks, the main elements of which of the thermal energy storage. One of the energy storage system that has become widespread in recent years is the mobile thermal energy storage that has tanks filled with heat storage material. Therefore, especial attention is paid to the search of new types of coolant, heat-accumulating materials, and research of their properties and determination of rational operating parameters. Specially created heat storage materials are often used. They work under the necessary technological conditions and meet the strict requirements for the safe transport of liquids. In 2020, a mobile thermal energy storage was created and tested for 3 heating seasons. In the period of 2022-23, it was used at the territory of the Rehabilitation Center of the Ministry of Internal Affairs of Ukraine. Mobile thermal energy storage consists of an accumulation section and a hydraulic section. 8 storage tanks of the capacity type are installed in the storage section. The design of each battery tank has 2 spaces. First tank is filled with the heat storage material. Second tank is filled with fast change materials. Experimental research, a test bench heat storage of capacity type was created. This tank consists of tank 1, which is filled with the heat storage material under investigation. The tank 2 contains phase change material which was selected in advance experimentally. The heat storage material is heated by an electrical heater 3. Temperature measurement is carried out with the thermocouples 4, which work together with the microprocessor module Triton 5. Samples of heat storage material under investigation placed in the tank 1. For creation the thermoaccumulating liquids in our experiments we used carbomethyl cellulose, xanthan and guan gum. These components are represented in this slide. After completing the research, an application for Ukrainian patent was submitted. The slide shows the order for conducting experiments. Each number of the experiment corresponds to a different chemical composition of the heat storage material. When analyzing the obtained experimental results in the following graphic figures, this correspondence is preserved. Maximum energy consumption per cycle was recorded in experiment number 1, where water heats of fast change materials, PCM. The lowest energy consumption per cycle was observed in experiment number 10, where the heat storage material includes antifreeze and xanthan gum in the amount of 1%. The difference between these experiments is 27.3%, which is a significant difference for the average consumer and acceptable for industry. Unacceptable for industry. The experimental period includes heating and cooling time, which is equal to 1 cycle. It can be seen in figure that the shortest cycle period was in experiment number 1, where the water heated the PCM. This fact can be explained by the abnormally high specific heat capacity of water compared to any other liquids. In experiment number 2, water was replaced with a heat storage material made of water at antifreeze, which increased by the cycle by 15%. But the longest cycle time is in experiment number 7, which is 24 longer than experiment number 1, which indicates an extended period of accumulation due to the addition of 1% guar gum. The ratio of the spent energy to the period of the heating-cooling cycle allows to assess the efficiency of the heat storage material. Therefore, experiment number 1 is the least effective as it requires a significant supply of energy with a minimum accumulation time. Experiment number 10 is the most effective as it has a lowest value of the ratio. In general, it is 34.8%. That is, when conducted the fuse research, xanthan gum is one of the priority components. The PCM sample, fast change material sample, in this case sarazine, was filled into tank 2 and was not changed throughout the entire cycle of experiments from experiment number 1 to experiment number 10. Mass measurements were carried out before and after thermal cycling. Some samples were weighted, electronic balance with automatic calibration. The initial mass before number 1 was 107.5 gram, and after the last experiment 10, the mass was 106.2 gram. This means that in the process of 40 thermocycling heating cooling, the mass changed within 1–2%. And this material can be used to fill the thermal core of mobile thermal energy storage. As a result of the conducted experiment studies, the expediency of using the water, antifreeze, xanthan gum, and guar gum as part of the heat storage material was established. Determining the concentration of these substances will be the subject of future research. The safety of using sarazine in the thermal core was also confirmed by studying the change in mass before and after thermal cycling. Thank you for your attention.